This is going to be the word problems that we were doing. So let's try them at this point. Let's see. This comes from the worksheet I emailed you. And so this is how we do those. So you guys that are not here, I'm going to go through these with you. I'm going to do them just like I did in class. Number one, the word problems where it says H represents the height of the tree in inches, T represents the year since Bob moved in. And then I give you an equation, H equals 210 plus 33T. Notice that normally we write this as Y equals MX plus B. Notice that instead of using Y, instead of using M, instead of using X, instead of using B, we're doing it a little bit differently. I'm going to see if I can make this a little bigger for you guys. There we go, much better. And do it that way. There. Shakes a little bit, but we can cope with that, I think. All right, so Y equals MX plus B. It doesn't matter whether it's Y or whether it's X. In word problems, typically you use letters that represent what you're talking about. In this case, it's saying you have a tree, you planted the tree, Bob did this cool tree, and you want to know how fast the tree grows. And they give you this equation. H represents the height, T represents the time. You get this equation. So the question is, how fast does it grow? Well, in this case, it's this M. It's this slope. That's 33 inches per year. That's how fast it grows. That's what that means. If I think of height is in inches, Y equals MX plus B, think of it this way. You have Y, which is going to be, in this case, H, X, which is in this case is going to be time. Is you're saying how many height per year, or how many inches per year. Time is in years, height is in inches. So, well, what is a slope? A slope is rise, height, over run, year. So it's inches per year. So that's what it's trying to get at, is what do these things mean when you throw them into an equation? Okay, question number 2. It says a young sumo wrestler wrestled and decided to go on a special diet to gain weight rapidly. W represents the wrestler's weight in kilograms as a function of time in months. So he's going to gain so many kilograms per month. Okay, so and then I give you the equation, weight equals 80 plus 5.4T, okay, or 5.4T plus 80. Either way, the equation's the same. So sometimes you'll see them one direction or the other, but it has the y-intercept, or it has the kind of what you started with, and then it has the rate. So this number here, the slope, another name for that is the rate. So if I go back to this one, it's inches per year. That's the rate. In this case, it's pounds per, what is it? It's rise, which is in pounds. So again, making a little chart here, is he's got a sumo wrestler. He's going to do pounds, that's kilograms, and in time, that's months. So your rate is going to be kilograms per month. So whatever this one is divided by that one. Remember, rise over run. So kilograms per month is the rate. And so in this case, he's 5.4 kilograms per month. The question is, what if he goes 2 months? Well, if it's 5.4 per month, 5.4 times 2 is 10.8. So that's how many kilograms per month, or that's how many kilograms he gains. So so the main thing I'm looking for here is when you see this equation, this thing, why we call it the slope in most problems, another way to think of it is the rate. Sometimes it's speed, sometimes it's height per inches. Usually it's clear in it, but whatever it is, it's that, whatever that unit is, over that, rise over run. Okay? All right, number 3. Bartholomew. Who's Bartholomew? I don't know, some weird dude. He took a loan from the bank. And so what about his nifty loan? Well, it says in the problem, D represents the bank, or Bart's, D represents Bart's remaining debt in dollars after T months. So I give you an equation, D equals minus 200T plus 9,000. Again, the y-intercept, y equals mx plus b. Well, in this case, it's not x and it's not y. It is D is debt, so that's debt, and that's in dollars. And T is time, and this one is in months. So I'm going to ask you a couple of questions just off the top. Is like, how much money per month does he get? Or how much does he have to knock off his loan? In other words, when he pays his loan, well, it's $200 per month. That's the rate, dollars per month. So he loses, or his debt is reduced $200 per month. What do you think the 9,000 represents? If I were to draw this, I would have over here at 9,000, and it would be a line that goes down like that, because his debt is going down every month that he goes forward. Well, 9,000 represents, well, if the time is 0, notice time is 0, that's where it crosses this line. That's the y-intercept. That's his starting amount. He borrowed $9,000. Okay. And then he reduces that 200 per month for the rest of the months. That's what these represent in real life. So that's number 3. Question is, how much money did he borrow? 9,000. Sorry, got a cold. Next. Next problem is a little bit more complicated, where I'm asking you to think about a bunch of things, and I'm giving you a scenario, a story. So here's the story. You've got it on your worksheet. It says, Bob the Tomato wants to start a t-shirt company. He will sell the t-shirts for $13 each. He has to spend $280 a month, that's what we call overhead, to pay for his equipment and electricity, plus $950 a month for his cost of materials. So every t-shirt, he's got to buy the shirt, he's got to buy the ink, he's got to, it costs him money every time he prints one of these shirts. So the question is, what's a linear equation that shows you how much money he makes? Well, I'm going to use a letter to represent money he makes. So I'm going to use, I don't like M because that's MX plus B. I'm going to use D for dollars. So how many dollars he makes is equal to, well, it costs him how much per shirt? Well, $13 for every shirt. So I'm going to say S represents the number of shirts. So typically when I do these, what I'll do is I'll either keep it in my head or I used to actually write these out. I would say D equals dollars made, and S represents number of shirts sold. So I would write that down so that if I had a complicated problem, I could go back and represent what they are. So when I have a big mathematical formula and it says this, this, and this, I know what those things are. I don't mix them up. And I try and pick letters that are going to be obvious. Again, I could have used M for money, but you're collecting dollars. Why not use dollars? And the number of shirts, I could have had N for number or S for shirts. I would have probably done one of those two on any given day. It doesn't really matter which one, but it should be clear. Okay, so I've got D. It costs him $13 for every shirt, plus it costs him $280 in a month. So in a month, how much money he's going to make is going to depend on how many shirts he makes, and that's going to cost. That's going to be what it costs him. This is what I call the cost. It costs him that much to make t-shirts. Okay. Sorry, I lied. Look at the thing. This is $950. $950, not. I didn't read the rest of the problem. It's $950 a month for the cost of the materials. He sells the shirts for $13 each. So the profit or the sale is the formula for dollars is going to be just $13 times however many shirts he sells. So really I have two equations. I have what it costs him in dollars, and it's $9.50 a shirt plus $280 a month. So in a given month, if he sells one shirt, it'd be $9.50 plus $280. It would cost him a lot of money for that one shirt. But he also makes money. For every shirt he sells, he gets $13 for it. You following me there? Okay, so this first question is, what's a linear equation that shows how much money he makes? Well, that's this one. That's how much he makes. Okay, then what's a linear equation? It's just how much money he spends, or in other words, it costs him that much. Okay. Now, how many t-shirts does he have to sell to break even? Well, if this and this are the same, in other words, if it costs him the same as he makes, then he breaks even. So I'm just going to write that as an equation. 9.5s plus 280. That's what it costs him. If that equals 13s, then all I have to do is figure out S, and that'll tell me how many t-shirts it takes to break even, because this is what it costs and this is what his profit is. So I just do the math, subtract 9.5 from both sides, minus 9.5, and I end up with 3.5 S equals 280. And that works out to be, just divide both sides by 3.5, and I get S equals, so divide by 3.5, and divide that by 3.5, and I get S equals 85. So he needs to sell 85 shirts, or he's going to lose money. If he sells more than 85 shirts, he starts to make money. So think about that as whenever somebody's running a business, your goal is not to break even, because when you work all that time, you've paid all your expenses, but you haven't paid for your work. And so as a business person, if you ever start a business, you need to do some simple math. What does it cost you? How many of these things do you have to sell? And then what are you going to make? That kind of stuff. So you're going to try and set those equal to each other to figure out what you've got to charge. In this case, if he figures he could sell 100 shirts in a month, okay, that means 15 of these shirts are going to be profit. 15 times 13, because 85, 100 take away 85, you get 15. So 15 shirts at $13 a piece, that's not that much money. He works an entire month for, and he gets a couple $100. That's not great. It's not horrible. It kind of depends on how long it takes him to make those shirts. If he can do them in an hour, a couple $100 in an hour is pretty good. If it takes him a month, that's not so good. So he has to decide, is it worthwhile to open a shirt factory here to make it work? So last one that we're going to do is question number 5, where it is Nero and Achilles start recording their video blogs. And they're hoping to regain support from Generation Z. These are old dead people. They decided they want a new thing, so they're going to make a cool video blog, and hopefully people will watch it. I don't know. So Nero starts videotaping, or I should say not videotaping. He takes his iPhone out and he starts recording himself. Nero's phone starts with 1,000 megabytes of free space, and it uses 7 megabytes per second of video. If I write the equation, the amount of space that Nero uses, so I'm going to use S for space. Space equals S. S is equal to, he starts with 1,000, but he uses, subtract, 7 megabytes per second. So I'm going to use T for time for second. So T is, space is S, T is time. And so that's what Nero, that's what he does. Achilles, his deal is he starts with 1255, but his is a much faster one. It uses up 13.5 it uses 10 megabytes per second. So he starts with more, but he uses it up at a higher rate. Again, this is the rate. This is it's how many megabytes used per second. That's again what we call the rate. So question number 1, it says write a linear equation that describes how much space is available for each guy. Well, this is it. Notice it makes a little more sense to have instead of y equals mx plus b, this one I put b in front and m and x second, because it's a little bit obvious. I could have written as space equals, he loses 7 plus 1,000. So this number here represents what did he start with. Or in other words, if t was 0 second, he's going to start with that. This one is a little more logical. This one is perfectly logical to me also. I did it this way. Just so you can see, I'm kind of taking away space. So this take away this makes a little more sense intuitively. So that's the first part, is write a linear equation for each guy. That's it. Now, how much time will it take for them to use up all the free space on their phone? Well, if I'm going to use up all the free space, let's start with Nero. How much space will be left? That means 0. And so that's going to be 1,000 minus 7t. Okay, add 7t to both sides. I get 7t equals 1,000. Divide both sides by 7. And I get t equals, and you do that math in your head, because everybody knows 1,000 divided by 7 is what? I don't know. This is why God made calculators, because he knew that we were not perfect beings, and we couldn't do this on our own, typically. So he says, I will give you an aid. I think that's in one of the Old Testament books. Don't quote me on that. 142.86 seconds. So you've got 142. That's about not quite 5 minutes. That's how much time Nero has. And if I look at Achilles, well, when he gets the 0, that's going to be 1255 minus 10t. Well, minus 10t from both sides, so 10t equals 1255. Divide both sides by 10. And so he's going to be 125.5 seconds. That I can figure out, because anything divided by 10, you just move the decimal place. So that's part 2. It's going to take Nero, he's going to get 142 seconds worth, and Achilles is going to get 125 seconds. Even though he started with more, he's using it up a lot faster. It makes sense that he would not have as much time. Last one is, what would it be if they had the same amount of space left? Well, that's if this space equals that space. Well, okay. So we just write those equations as 1,000 t, or 1,000 minus 7t equals 1255 minus 10t. So you're really just saying that this equals that. So I just say that equals that. And do the math. Add 10t to both sides, I get 3t. Subtract 1,000 from both sides, I get 255. Divide everything by t, or divide everything by 3, so I get 1t equals that. I get 85. So at 85 seconds, they're going to have the same amount of space left. And he's going to go for a total of 125. Nero's going to go for 142. Okay, so that's how you do those. Now, you can go back and kind of think that through, but that's what we went through in class. We're going to start working on word problems, how to do this process. So this was an introduction. What I'm looking for is that these skills that the basics that you're seeing on your test on the other page go with the beginning of, now how do we use and how do we apply these, and we get some practice with it. So basically, you're now, if you get to here, you're now blue belt. So, and your goal is to get better and better and better and better. Okay. But it's the same as in karate, in the sense that as a blue belt, you'll be on some of these techniques when you're putting them together. But even as a brown belt or black belt, you're going to do the same techniques. You just do it better and faster. But it's the same process. You do the exact same thing. And then where it gets tricky is you then have to decide, ooh, what kind of attack is this? What should I do? I'll do this. And then you successfully carry it out. That's what we call actual problem solving. So this is practice towards actual problem solving. Anyway, talk to you soon. Bye.